Good day, everyone. Welcome to the Sea Power Report. I'm your host, Wei. Today's topic, design of a modern destroyer. The question of how to design a modern destroyer is becoming increasingly complex, as naval warfare in the 21st century is becoming increasingly complex, with factors like electronic warfare and the integration of unmanned systems. So making sure that the destroyer you build has the right mix of weapon systems, radar, sonar and other sensors, and blue water capabilities is particularly important given these rapidly evolving trends in modern naval warfare. Now, before a ship can be designed and built, there needs to be funding. However, this video will skip the funding stage, because the legal, budgetary, and approval mechanisms in the political process for approving naval funding differs significantly across different countries. Some are more opaque than others. For these reasons, the political process for setting naval budgets is a huge topic of its own, which we will not go into. In this video, we will focus on the tangible and observable stages of designing a destroyer. There are essentially three main stages in the design phase. The first is the conceptual design phase, where naval engineers and military strategists get together to define the new destroyer's mission profile. They look at the ship's intended role, whether they be anti-submarine warfare, area air defense, or surface warfare, or a combination of all of these. They then come up with several alternatives given these mission requirements, and then recommend a preferred option. There are several important emerging trends in naval ship design that needs to be taken into account in the conceptual design stage. The first is modularity and configurability, which is the ability for certain ships to be configured via modules for certain mission requirements depending on what is needed. For example, the ship might be equipped to conduct anti-submarine warfare one day and mine countermeasure another day. Another emerging trend is stealth and radar cross-section reduction. Essentially, nearly all modern destroyers include stealth capabilities to some extent, some more so than others. The tumble-home design of the US Zumwalt-class destroyers is one such example. Another trend is novel propulsion systems, for example, integrated electric propulsion or turbo-electric drive of some sort. They have the potential to be quieter than traditional propulsion, which can be important for anti-submarine warfare vessels. Another trend is the gradual emergence of unmanned systems. These include helicopter drones operating from the flight deck of a destroyer, or submarine drones that could play a role in mine countermeasure or anti-submarine warfare. The second stage of destroyer design is the preliminary design phase. This is when the chosen conceptual design is refined into a workable design that can be built. This phase determines whether the concept is technically and economically feasible given the technological and funding constraints. It translates the mission requirements that has been determined at the conceptual stage into a concrete ship specification. It determines how major systems will be placed and supported. For example, the propulsion, the sensors, the weapon systems, and the crew habitation. This is when the designers ensure that the ship can be sufficiently stable, can operate under a range of different sea states, has enough power generation to do what it wants, and has high enough seakeeping for its operational requirement. The third stage is the most intense and arguably the most critical. This is when the ship's preliminary design is fully fleshed out and finalized. Every aspect of the ship, from the bulkheads, the windows, the wiring and the piping, are fleshed out with precision. The phase finalizes the integration of the weapons, the sensors, the various electronic systems, for example communication, the propulsion, and the power generation. All of these things must work together as planned. This is where the builder will typically produce a full-scale digital model of the destroyer. We will now go through in greater detail all three stages of destroyer design, from the conceptual design to the preliminary design, and finally to the technical or detailed design phase. Although we will place more emphasis on the conceptual design and the preliminary design phases. I will talk about the last part, the technical design phase, briefly, but that is a topic best covered by a real naval engineer. So let's get right into it. So to begin with, we have the conceptual design phase, where the vision of the new destroyer is created. Essentially, the phase answers the question, what is the new destroyer going to be doing? In this phase, the key stakeholders, from the naval architect to the military strategist, get together and answer a few key questions. Firstly, what is the ship's mission profile? Will the new destroyer be primarily tasked with area air defense, anti-submarine warfare, or escorting aircraft carriers? Or will it be intended more to fight independently of its carrier battle groups, in which case it may be more armed with anti-surface and anti-shipping capabilities? Will the new ship be expected to operate on a global basis, in a blue water navy, or will it be part of more of a regional navy, like a green water or littoral navy? Is the vessel intended to participate in high-intensity conflicts with a peer or near-peer adversary? Or is it more suited for low-intensity conflicts against nations that can't really fight back? Do you have gray zone operations in mind, coercive actions that fall below the threshold for war and that blurs the line between war and peace? Or is the ship going to be part of an anti-piracy and anti-terrorism task force? These are all key questions to be answered before determining the ship's capabilities. Once you have determined the ship's mission profile, you can then move on to high-level operational requirements. These may include the ship's top speed and cruising ranges. For example, in a blue water navy, if the destroyer is supposed to operate as part of a blue water navy, then it may be expected to have a larger cruising range. It may also be expected to have a high endurance, being able to operate for more days at sea without resupply. Its crew habitation may be higher in quality, providing greater crew comfort on a long mission far away from home. It may accommodate a larger crew size than otherwise, allowing for more rotation between crew members. If the ship is purpose-designed to be part of a larger naval formation, then you may want to think about whether you want to include command and control capability for the destroyer. This is particularly relevant in smaller navies where destroyers are one of the largest surface combatants. The threat environment, given your mission profile, will then determine what sort of armament and radar and other sensors you want to have on board. For example, if you're expected to come up against anti-ship ballistic missiles, then you would want to include some sort of anti-ballistic missile capability. If the main aerial threat is expected to be cruise missiles, then things like point defense systems like Sea Whizzes and short-range missile launchers would be important. Given it's highly likely that the ship will be escorting a valuable capital ship like an aircraft carrier, then some form of medium-range area air defense is desirable. For example, the Standard Missile 2 on American Arleigh Burkes. If longer-range theater-level air defense is required, then something like the SM-6, the Standard Missile 6 air defense missile, is essential. You may be expected to guard against submarine threats, in which case the ability to accommodate an onboard helicopter for anti-submarine warfare, including both a hangar and a helipad to operate the helicopter, will be important. Not to mention things like sonar systems, including towed sonar systems and variable depth sonars, and torpedoes are also essential. Finally, you may expect to operate in an environment with high electronic warfare threats, in which case you would want high levels of electronic warfare capabilities. The threat landscape determines not only what types of weapons you want to carry, but also what sensors and radars you want to install on board as well. If this is an air defense destroyer, then you want powerful ASAR radars, and you will likely want multiple radar systems for different functions and situations. For long-range volume search of aerial threats, you would want large panel ASAR radars providing 360-degree coverage. These long-range radars should be in the airspan, strictly speaking. You would want to complement that with shorter-range X-band ASAR radars for fire control purposes within the radar horizon, for the best chance at intercepting sea-skimming anti-ship missiles. For anti-submarine warfare ships, radar is probably not as important. In their cases, sonar becomes much more important, obviously. These include not only the standard hull-mounted sonar, which almost all naval ships should have, but also the towed sonars at the stern. They include a towed array sonar for expanded passive sonar detection, and a variable depth sonar for greater active sonar detection in different layers of the ocean where submarines could be hiding. And the key electronic systems include not just the sensors, but also things like interoperability. If the destroyer is expected to operate frequently with elder-friendly naval ships, or with naval ships of allied nations, then some level of CEC or cooperative engagement capability would be desirable. This is particularly important for navies that frequently participate in joint and coalition naval operations, such as the US and NATO navies. The rationale behind coming up with all of these high-level capabilities is to be able to map all of the mission requirements specified at the start to a specific capability to be installed on the ship, so that the conceptual design of the ship can perform its mission requirements. From here, multiple different options for different destroyer designs are then created, and these can vary along a number of dimensions. For example, displacement and hull form, the ship's propulsion and power plant, and the mix of weapons carried on board. For example, the number of vertical launching systems, the VLS, the caliber of the main gun, and indeed the number of gun barrels, and finally the number of point defenses, such as seawards. The naval architects come up with a number of high-level destroyer design for the decision-maker to choose between. By the end of this process, we have a set of what should be viable design alternatives. And from here, the decision-makers choose a recommended baseline design among a list of viable candidates. This recommended baseline design, along with any modifications, then form a proposal for moving into the preliminary design phase, which is the second stage of destroyer design. As I said before, the process for coming up with this recommended destroyer concept should have accounted for the key emerging trends in naval warfare, including stealth and radar cross-section management. Modularity and configurability. This means the potential to modify the ship on very short notice for different mission profiles, depending on what the situation requires. There should be consideration of novel propulsion systems, including integrated electric propulsion. And thinking should have been done around incorporating unmanned systems, for example, helicopter drones and submarine drones. So now we can finally move on to the preliminary design phase. The preliminary design phase represents the transformation of these on-paper capabilities and ideas into a better defined and technically feasible destroyer. It translates high-level concepts into an integrated destroyer plan, into a configuration of the different systems, and making the engineering trade-offs. For example, between stability and the height of the radar mast, that's one example, and between the ship's displacement and estimated construction cost. Preliminary design can take several years, based on the complexity and novelty of the new destroyer class. By the end of this, the destroyer's blueprints should have resolved all the major engineering constraints and produced a mature enough design for things like cost estimation and risk assessments in the early stages of production planning. In the preliminary design phase, the engineers would have finalized the ship's basic hull form for factors like hydrodynamic efficiency and the radar cross-section. They would have made efforts to achieve an acceptable level of stealth. They will have determined the placements of the key components for the ship, including the weapons, the sensors, the key structure, the propulsion, the power generation, and the crew habitation. Extra space will have been reserved for future upgrades. For example, the installation of new weapons like direct energy weapons over time. The required cooling systems will have been determined for the key electronic systems, especially the radars. Key weaponry, especially the points defenses such as the seawards, will have been placed so as to minimize the amount of blind spots and to produce overlapping fields of fire. By the end of this phase, the initially recommended destroyer concept will have been transformed into a viable and coherent destroyer design that can be costed and fleshed out with more details. Now let's talk about the last stage of the design process, the detailed or the technical design phase. By the end of this phase, the destroyer's blueprints should have become precise enough to start building the ship. Every part of the ship, hull, engines, weapons, the wiring, plumbing, and ventilation, is drawn out and engineered to exact specifications. By this point, the ship's shape and systems have already been decided, but they're now further broken down into thousands of detailed plans for each section, pipe, and cable. Shipbuilders, engineers, and suppliers work closely to make sure that everything fits together in the real world. Mistakes not caught here can have huge cost later on. Advanced digital 3D models help check for conflicts, like making sure a pipe isn't running through a wall or blocking a hatch. The phase will also produce detailed instructions on how the ship should be built. For example, in what order to assemble the different parts, and how different blocks will be welded together, and the order in which the crew install the different weapons and sensor systems. The detailed design phase can take between 1 to 3 years, by the end of which construction can begin with confidence. So there you have it, the 3 stages of destroyer design. First we have the conceptual design stage, where the main question to be answered is, what type of destroyer do we want, and which destroyer concept best achieve that? The second, preliminary design phase, flesh out this concept with an actual concrete destroyer design. The third phase, the technical, detailed design phase, transforms this preliminary design into an accurate and precise destroyer blueprint, one that can be used for construction. The length of time for the overall design process can take anywhere between 4 to 10 years, depending on the competency of the design team and the novelty and the complexity of the ship being designed. That will be all. If you have enjoyed this video, please give me a thumbs up and do subscribe to my channel. See you next time.